Chapter 6, 6.6 to 6.10, quiz review. Number 1, a population of 20 rabbits is released into a wildlife region. The following table shows the growth. First one to fill out the table, in year 1995 is the year that we first released them. So that's year 0. And so I'm going to fill out the rest of this based on the fact that that is year 0. Okay, now I need to find my successive quotients. So I'm going to bring up my handy dandy calculator, and I like to start at the bottom. 14,580 divided by 4,860, and I get 3. 4,860 divided by 1,620, and I get 3. 1,620 divided by 540, and I get 3. 540 divided by 180, and I get 3. 180 divided by 60, and I get 3. 60 divided by 20, and again I get 3. So my successive quotient is 3 all the way down or 3 all the way up, however you want to do it. But my successive quotient is 3. Write a function rule for the data. So I'm going to do this up here. Y is equal to, my starting point A is 20, because that is Y when X is 0, times B. My B is the successive quotient, the common multiplier 3 to the X power. Is the function exponential, growth, or decay? It is growth. How do I know? Because the successive quotient is greater than 1. Find the population in the year 2006. The year 2006, so I take 2006, I subtract 1995, and I am going to get 11. So I want to do 11 years. So that means I want my equation to be 11. So I'm going to go to y equals, and I'm going to plug in my equation 20 times 3 to the x power to the x power. I'm going to go to my table, and I want 11. So 11, I have 3,542,940. 3,542,940. And what year will the population be 10,600,000? Well, we can continue in our graph. That's 10,628,820. That is year 12. But that's the 12th year, which means I have to take 1995 and add 12. So that's 2007. All right. Number 2. The purchasing power of $1 from 1982 to 1997 is shown in the following table. Find the successive quotient. Again, 1982 is the first year, so that's 0. So this is 1, 2, 3, 4, 5, and 6 years. I want to find my successive quotient. So again, I bring up my calculator. And again, I want to divide this out. I like to start at the bottom, 0.80754 divided by 0.83683. I got 0.965. Continue in my calculator, 0.83683 divided by 0.83683. 0.6718. I get 0.965. Continue with my calculator. Continue with my calculator. 0.86718 divided by the one above it, 0.89863. I put 2 decimal places. 0.965. Continue with my calculator. 0.89863 divided by 0.93123. 0.965. Do you see a pattern? Continue with my calculator. 0.93123 divided by 0.965. I get 0.965. And lastly, 0.965 divided by 1, I get 0.965. And the first one, again, is left blank. So my successive quotient is 0.965, 965 thousandths. Write a function rule for the data. I'm going to write it down here. I have y is equal to, my starting value is y when x is 0, so that is 1, times my successive quotient or common multiplier, 0.965 to the x power. Is the function exponential growth or exponential decay? It's exponential decay. How do I know? Because my successive quotient, 0.965, is less than 1. Find the purchasing power of the year 1992. Again, I want to take 1992 and subtract 1982, and I get 10 years. I go to my handy dandy calculator. I go to y equals. I'm going to plug in my equation. My function is 1 times 0.965 to the x power. I'm going to go to my table and I want 10 years. In 10 years, it's going to be 0.58602. Didn't want that over there. 586. So $1 in 1982 is only worth about 59 cents in the year 1992. In what year would the purchasing power of the dollar be 61 cents? Go back to my calculator. 61 cents is going to be about 14 years. About 14 years. Okay, let me back up. I don't know why I just did 15, so excuse me. Find the purchasing power in the year 1992. 1992 we said would be 10, so that would be 70 cents. This is 70 cents. When will the purchasing power be 61 cents? 61 cents, like I just did, would be about 14 years. So then I have to do 1982 plus 14 would be 1996. So this is year 1996. Sorry about that. This is 70 cents. This is the year 1996. Number 3 you have below. I put it on another page so that I would have more room. So number 3, determine Whether each table demonstrates a linear, quadratic, or exponential relationship. If it is exponential, state whether it is exponential growth or decay. Find the function for each. So I'm going to start by successive quotients to see if it would work first. So 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, 48 divided by 24 is 2. So this is exponential. My successive quotient is 2, so this is exponential growth. And so then my function is y is equal to y when x is 0, 3 times 2 to the x power, my successive quotient. Number 2, if I look at this, 5 divided by 3 is not going to be the same as 7 divided by 5. So I am going to go ahead and do differences. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2. So this is linear. So y is equal to m. That's my first difference, 2x plus b. b is y when x is 0, so plus 3. Okay, let's look at C. This looks like this is going to be exponential decay. So I'm going to get out my calculator and I'm going to double check, and I'm going to go ahead and take 0.8 and divide by 2 and get 0.4. Take 0.32 and divide by 0.8 and get 0.4. Take 0.128 and divide by 0.32. Remember, I'm taking the bottom one, dividing by the one above it. 0.0512 divided by 0.128. And I'm getting 0.4 every time. And again, I'm doing divisions. So this is exponential. And since my successive quotient is less than 1, this is decay, D-E-C-A-Y. And then I need y is equal to, my starting value a is y when x is 0, so that's 2 times my successive quotient, 0.4 to the x power. This last one, if you notice, my numbers go down and then they go back up. And so that tells me more than likely this is going to be quadratic. But let's do our differences. 4 minus 7 is a negative 3. 3 minus 4 is a negative 1. 4 minus 3 is 1. 7 minus 4 is 3. That was a negative 1. So continue. My first differences are not the same. Try my second differences. Negative 1 minus a negative 3 is going to be 2. 1 minus a negative 1 is 2. 3 minus 1 is 2. So I know that this is quadratic. And I know the equation is y is equal to ax squared plus bx plus c. My a is half the second difference. So a is 1. My c is y when x is 0, so this is 7. My b, to find my b, I have to do my first difference, negative 3, is equal to a plus b. But I know that a is 1. So to solve for b, I subtract 1, and I get negative 4 is b. So my equation is y is equal to 1x squared minus 4x plus 7. All right. E, F, and G, again, I gave myself a little more space here. Looking at letter E, it looks like this is going to be exponential growth. Get out my handy dandy calculator. Let's check. So let's go ahead and take 3.5 and divide. That's a lie. I have to take the bottom one, divide by the one above it. 6.125 divide by 3.5. And I get 1.75. Take 10.719 divide by 6.125. And I get 1.75. Take 18.7 0.758 and divide by 10.719. And I get 1.75. Take 32.826 and divide by 18.758, and I get 1.75. So my successive quotient all the way down is 1.75. So I know that this is exponential. I know it's growth because my A term, my B term, my successive quotient is greater than 1. So then my equation is y is equal to y, when x is 0, 3.5 times my successive quotient 1.75 to the x power. Let's look at the next one. I'm not sure what this is right off the bat, so I'm going to do my successive quotients, and if that doesn't work, then I'll try differences. Okay, so if I do -1 divide by -3, I get 3. If I do 5 divided by -1, I'm going to get -5. If I do 15 divided by 5, I'm going to get a 3 again. If I do 29 divided by 15, I'm going to get 2. None of these work. So this is not exponential. So let's do our differences. -1 minus a -3 is 2. 5 minus a -1 is 6. 15 minus 5 is 10. 29 minus 15 is 14. Let's continue with my differences. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. So this has to be quadratic. So that means I need y is equal to ax squared plus bx plus c. My a is half the second difference, so half of 4 is 2. My c is y when x is 0, so that's -3. To find b, I need my first difference is 2. That's equal to a plus b. A, I already know, is 2. So I'm going to subtract 2 from both sides, and I'm going to get b to be 0. So my equation is y is equal to 2x squared plus 0x minus 3. And there's my quadratic equation. Let's do the last two, g and h. Again, I want to start by checking my successive quotients to see if this is exponential. So I'm going to take 3 and divide by 4. I get 0.75. Take 2.25 and divide by 3. And I get 0.74, which is almost 0.75. Take 1.6875 and divide by 2.25. Now I did make a, okay, this should be 0.75 right here. I typed in 2.23 instead of 2.25. If I had done 2.25 divide by 3, I would get 0.75. And the last one, 1.2656 divided by 1.6875, and I get about 0.75. So again, my successive quotients are all 0.75, 0.75, 0.75, 0.75. That tells me it's exponential. It tells me it's exponential decay because my successive quotient is less than 1. So my equation is y is equal to my starting value. My initial value, y when x is 0, 4 times my successive quotient, 0.75, to the x power. And let's do h. Again, because of all the decimals, I believe it's going to be exponential. So take 1.25 divided by 0.5, and I get 2.5. Take 3.125, 0.125, and divide by 1.25, I get 2.5. Take 7.8125 and divide by 3.125. I drop the decimal, that would be 2.5, and 19.531 divided by 7.8125, and I get 2.5. So my successive quotient all the way down is 2.5, 2.5, 2.5, 2.5. So this is exponential. I know that it's exponential growth because my successive quotient is greater than 1. So my equation is y is equal to my y value when x is 0, my initial value, 0.5 times my successive quotient 2.5 to the x power. All right, let's go to the next page. How much time have we done so far? 21 minutes. All right. Use transformations to describe the graph of each function as it relates to the function y equals 0.78 to the x power. Letter A, I've added 3 on the outside, so this is a translation or a shift up 3. For letter B, I have a 2 in front, so this is a vertical stretch. Vertical stretch by a factor of 2. Letter C, I have a -4 on the outside, so this is a translation or a shift down 4. This is a 0.45 in front, so this is a vertical compression by a factor of 0.45. Letter E, I'm doing 2 things. I am doing a shift, a translation, up 5, and I'm doing a vertical stretch by a factor of 1.7. And lastly, here I'm going to do a shift or a translation down 1, and then I'm going to do a vertical compression by a factor of 0.6. Since that number is less than 1, it's a compression. On letter E, it was greater than 1, so it's a vertical stretch. Number 5, in each of these, the table represents a transformation of y equals 3 to the x. Write the function that fits the transform data. So I'm going to go to my calculator. I'm going to go and plug in 3 to the x power. I'm going to pull up my table, starting with 0. And now I've got 2 options. 0 is going to -2, but it should go to 1. What do I do to 1 to make it -2? I can either multiply by -2 or I could subtract 3. I'm going to subtract 3. So if I subtract 3, I get 0. If I subtract 3, I get 6. If I subtract 3, I get 24. If I subtract 3, I get 78. So my equation turns out to be let's get rid of these real quick. Y is equal to 3 to the x minus 3. Let's look at the next one. If I look at the next one, again, 1 needs to be 2, 3 needs to be 6, 9 needs to be 18, 27 needs to be 54. It looks to me like I'm multiplying by 2. So 1 times 2 is 2, 3 times 2 is 6, 9 times 2 is 18, 27 times 2 is 54. So that tells me that my equation, instead of adding a c, I'm going to have an a in front. Y is equal to 2 times 3 to the x. And lastly, 1 needs to become 4, 3 needs to become 6, 9 needs to become 12. It looks like I'm adding a 3. 1 plus 3 is 4. 3 plus 3 is 6. 9 plus 3 is 12. 27 plus 3 is 30. So again, it looks like my equation is y is equal to 3 to the x, and I'm going to add a 3, and I can try that for any of these and make sure it works, and that's how I do those translations. Application problems. Let's talk about growth and decay. So I look inside the parentheses. This is greater than 1, so this is growth. My initial value is the 250, which is my A, my initial value. I like to fill out the last column first. My growth factor is 1.25, which means my percentage of growth is the difference from 1. 0.25 as a percentage is 25%. The next one, inside the parentheses, is less than 1, so this is decay. My initial value is what's in front, which is 4.5. My last column, what is in the parentheses, is 0.87. The difference from 1 is 0.13, which is 13%. Again, look in the parentheses, 1.5 is greater than 1, so this is growth. The number in front is my initial value, which is 3,000. Fill out the last column. The number in the parentheses is 1.5. The difference from 1 is 0.5, or 50%. Okay, so in the parenthesis, I have 0.45, so this is decay. The number in front of the parentheses, there's nothing there, so we assume it's a 1. What's in the parenthesis is 0.45. This is less than 1. That's how we got it to be decay. So the difference from 1 is 0.55, or 55%. Inside the parenthesis for the next one is 2/3. It's less than 1, so that is decay. The number in front is 3, so that's my initial amount. Inside the parentheses is exactly 2/3. The difference from 1, which is 1/3, or 0.33, which is 33.3%. Again, you can use your calculator for those. The last one inside the parenthesis is 2.5. So this is growth because it's greater than 1. My initial value, what's in front of the parentheses, is 50. Percentage of growth, again, I would like to do the last column first. This is 2.5 in the parenthesis. The difference from 1 is 1.5, which is 150%. All right. Number 2, write an exponential model for each situation. Use the variable t for time. A newly hatched channel catfish typically weighs 0.3 grams. During the first week of its life, its weight W increases by 10% each day. So this is exponential growth because it's increasing. Remember, exponential growth is y is equal to a times 1 plus r to the t power. So this, my weight, and it's increasing per day. So my weight is equal to my initial amount, 0.3 grams, times 1 plus 10%, so 1.10 to the t power. You bought a used car for $18,000. The value depreciates 12%. Remember, this is decay, so this is a times 1 minus r to the t power. So the value V is equal to my initial amount of $18,000 times 1 minus 0.12, which is 0.88 to the t power. 1 minus 12%, or 1 minus 0.12 is 0.88. A business earns $85,000 in 1990, then it earns E decreased by 2% each year. Its earnings, E, decreased by 2% each year. So my earnings, this is decreased, so I want to use this is over here. I started at $85,000. I'm decreasing by 2%, so 1 minus 2%, or 0.02, is 0.98 to the t power, where t is the number of years since 1990. And lastly, a business had $20,000 profit in 1995. Then the profit increased by 20% per year. That means I'm going to use my growth. So P, my profit, is equal to my original amount, $20,000, times 1 plus 20%. Well, that's going to be 1.20 to the t power, where t is the number of years since 1995. All right, last page. As a chambered nautilus grows, its chamber gets larger and larger. The initial chamber volume is 0.787. Each chamber volume is 6.3% larger than the previous chambers. A, write an equation for the volume. This is increasing, so again, y is equal to a times 1 plus r to the t power. I want to write the equation, so my volume is equal to my initial amount, 0.787, times my base, or my common multiplier, which is 1 plus 6.3%, so 1.063 to the n power, since n is the number of chambers. How many additional chambers have to grow on the Nautilus to have a volume of 1.207? So I'm going to pull up my handy dandy calculator. I'm going to go to y equals. I'm going to clear that out. I have my equation of 0.787 times 1.063 to the x power. I want my volume to be 1.207. I'm first going to check it with my table. 1.207 is 7 chambers. So 7 additional chambers. What is the volume of the Nautilus when 4 chambers have grown? So 4 chambers has a volume of 1.0048. So we're going to say 1.005, and these are centimeters cubed, cubic centimeters. What is the okay, number 4, Sam puts $3,000 into a savings account that earns 6% interest annually. Annual interest rate is the same as exponential growth, so that's what we have in blue. Run an equation, blue as in what's up here. Run an equation for the total amount of money A that the account will be worth in T years. So A is equal to my initial amount, $3,000, times 1 plus my rate, which is 0.06 to the T power. How much money will Sam have in his account in 12 years? So again, I go to my calculator, I hit y equals. I'm going to clear out, put in my new equation. Which is 3,000 times 1.06 to the x power. And now I want this to be in 12 years. So I'm going to hit second graph, and I'm going to go to my table, which is 12 years, is $6,036.59. $6,036, and I believe I said 59 cents. 58.9 is 59 cents. Okay, how many years will it take Sam to have a total of $5,000 in his savings account? Let's go back. Okay, it's somewhere between 7 or 8 and 9 years. If I want to get more exact than saying during the 8th year, I'm going to go ahead and graph this. I'm going to go to y equals, and I want to have $5,000, so I'm going to put that in y2. I'm going to make my y's go past $5,000, so I'm going to make it 6,000, not 60,000, 6,000. I know it's somewhere between 7 and 8, so my x max is 10 is fine. I'm going to graph this. And if I can see the intersection, I can find the intersection. Second, trace to go to the calc menu. Number 5 is intersection. Hit enter 3 times. 1, 2, 3. And I get 8.7669, so 8.77 years. Okay, like I said, between 8 and 9 years, 8.77 is a lot more precise. That's what I want. Number 5. Let's see, where are we? We're at 38 minutes. Okay. Number 5. In 1995, you bought a 32-inch television for $600. The television is depreciating at a rate of 8% per year. Run an equation for the value V of the television in 4 years. Again, this is depreciation. So y is equal to a times 1 minus the rate to the t power. So write the value, the equation for the value V of the television after 4 years. Okay. So I'm going to start off with my original amount of money is $600. And this is 1 minus 0.8, which is 0.92. It's minus 8%. 0.8%, 8% is 0.08. 1 minus 0.08 is 0.92 to the t power. 4 years would be as a 4 there. What year would the television be worth less than half its original price? So technically for this one, since it says 4 years, I would put 4. I just want the equation, not the amount. What year will the television be worth less than half its original price? So there's a couple ways of doing this. I'm going to go to my calculator. I'm going to go to y equals. I'm going to plug in my current equation, 600 times 0.92 to the x power. I want half its original price. Its original price is 300. I can go to the table. I can go to the graph. If I'm going to do the graph, I need more than 600 since that's my original amount. So I can go up to 700. I don't know. If I hit second graph to go to the table, $300 is somewhere between 8 and 9 years. So my x's 10 years should show that to me. So I'm going to go to my graph. There's my graph. There's my intersection. If I can see it, I can find it. Second trace. Number 5 is intersection. I can hit enter 1, 2, 3 times. 8.31 years. What year? So this is 8.31 years. But what year is that? 1995 plus 8. So that would be 2003. Between 2003 and 2004. What will the television be worth in the year 2010? 2010 minus 1995 is 15. So if I go to my table, second graph, go to the table, the 15th year would be $171.78. $171.78. All right, compound interest. Compound interest. Erica is trying to save her money Erica is trying to save her money so she can complete a semester abroad during her junior year in college 6 years from now. She wants to invest her money in a savings account at a bank that offers an interest rate of 7% compounded over different periods. Write an equation and figure out how much money Erica will have in her account after 6 years for each compounding option. So $600 invested at 7% compounded annually for 6 years. So I have annually, more often, and continuously. Annually, A is equal to my principal, 600, times 1 plus my rate, which is 0.07, to the 6th power. Pull up my handy-dandy calculator. I'm not going to go to y equals. I'm going to go to a blank screen. I'm going to do 600 times 1 plus 0.0. I need to make sure to hit the 0.07 to the 6th power is $900.44. Okay, now let's do it semi-annually. So this is now going to be the more often. So this is A is equal to 600 times 1.1 plus 0.07 divided by 2 to the 6 times 2 power. So I'm going to hit second enter to bring up my last entry. 1 plus 0.07 divide by 2 to the open parentheses 6 times 2. And the calculator will do it all for me. $906.64. $906.64. $906.64. Compounded quarterly, A is equal to my original amount times 1 plus 0.07 divided by 4 now to the 6 times 4. Again, pull up my calculator. I want to bring up what I had left, so I put second entry. But instead of a 2, I want to make this a 4. Too far. Divide by 4. And I want to make this a 4 as well. $909.87. $909.87. Okay, now I want to do this weekly. So my equation is A is equal to my initial value, $600. 1 plus 0.07 divided by weekly is 52 to the 6 times 52 power. So second, enter to bring up what I had last. I want to divide by 50. I'm going to hit second, delete, so I can add a 2. And this is 6 times 52 in parentheses, because that's my power. And I'm going to get $912.92. $912.92. All right, and now we want to do continuously. Now I'm going to use my third equation continuously. A equals PERT. So A equals my original amount times E to the R. Let's get rid of that parenthesis. 6 times E to the RT power. My rate is 0.07 times 6 years. So now I pull up my calculator. I'm going to go 600 times E second ln, which is 0.07 times 6 years. I get $913.18. $913.18. Which option will earn Kayla the most money for her European trip? This is actually Erica, not Kayla. And it's going to earn the one that's going to earn the most is going to be compounding continuously. Run an equation and solve the following problems. Suppose $20,000 is invested at 9% compounded monthly. How much money to the nearest cents will be in the account after half a year? And then after 12 years. So my equation would be y is equal to my original amount, $20,000, times 1 plus my rate, 0.09 divided by 12, since I'm compounding 12, times 12 to the 12 times 0.5 for half a year, and times 12 for 12 years. So bring up my calculator. This is going to be 20,000 times 1 plus 0.09 divide by 12, since I'm doing it monthly, close parentheses, to the open parentheses 12, since I'm compounding monthly, times 0.5 for half a year. And that's $20,917.04. That is $20,917.04. Now how about for 12 years? For 12 years, I'm going to hit second, enter to bring up what I typed in last. The only thing I have to change is this 0.5 to a 12, because I'm going to change the amount of time. Now it's going to be $58,656.74. $58,656 and what was that? 84 cents? 74 cents. Claire invested $12,500 in the savings account at 8% compounded weekly. How long should she leave the money in the account? Ignore that. If she wants $15,000, we're going to do B down here. we're going to say y is equal to my initial amount, $12,500, times 1 plus my rate of 0.08 divide by 52, since I want it weekly, to the 52 times x. I don't know how long. I want to find how long, but I want to be able to make $15,000. So this is where I go to my calculator. And I go to y equals, I'm going to plug in 12,000. Let's come up here and plug in $12,500 times 1 plus 0.08 divide by 52 to the open parenthesis 52x. Close parenthesis. I want my denominator to be $15,000, and I want to find where these two lines cross. So I'm going to change my y max to be 16,000. I'm going to make my x max 25 to see if that's where they cross. If I graph, there's one line, there's the other line. I can see where they cross. Second, trace. Number 5 is intersection. Hit enter 3 times, and I get 2.28. So 2.28 years. All right. Okay, so letter C. Amy wishes to have $20,000 in cash for a new car 7 years from now. How much money should be placed in the account now if the account pays 8.25% compounded quarterly? All right, so this is letter C. I want to have $20,000. Okay. I want to know how much money should she put into it if it's going to pay. So this is 1 plus, my rate is 0.0825. Compounded quarterly means to divide by 4, and I want to do this for 7 years times 4. And that's all in my exponent. There's a couple ways of doing this. I could do this algebraically, but I'm going to do this in my calculator. And again, I'm going to go to y equals. I'm going to plug in my two equations. My first equation is x. My first equation is x times 1 plus 0.08. Okay, I messed up. Plus 0.0825 divide by 4, since I'm compounding quarterly, to the 7 times 4. Now this is technically a linear equation. I want this 7 times 4 in parentheses because that's the entire thing is my exponent. It's a linear equation because x is not in the exponent. It is my principal, which is missing. My y2 is the $20,000 that I want to earn, and I want to find where these cross. Now, x that I'm looking for is going to be some sort of $5,000, $10,000, $15,000. So my x and y window need to probably be above this 20,000. So I'm going to make it 21,000. And I want to see where these two lines cross. If I can see the intersection, I can find it. Second, trace. Number 5 for intersection, enter 3 times. And that means I need to have $11,292.14. Now, technically, it's 14.12, which means $14.14 wouldn't be just enough. So 15 cents, if I round up, will make sure I get my entire $20,000 and I'm not short anything. Letter D. Letter D says if you invest $500 at 4% interest compounded annually, how many years would it take for your initial investment to double? So again, I want to double. So I want to go from $500 to $1,000. My initial amount is $500. Compounding annually is 1 plus my rate, which is 0.045. Now, annually means I'm not compounding anything extra, so this is to the t power. I want to find what this is. So again, I'm going to pull up my calculator. I'm going to use intersection the way that I have been. Y equals, clear out these two. My first equation is 500. My first equation is 500 times 1 plus 0.045, 4.5% to the x power. I want to make $1,000. Now here my x is in the exponent, so my x's don't have to be too huge. We're going to try 50 years. My y's, I have to go above that $1,000. We're going to make it $1,200. I'm going to graph. There's my first graph. There's my second. If I can see the intersection, I can find it. Second trace to go to the calc menu. Number 5 is intersection. Enter 3 times. And it tells me in 15.75 years. 15.75 years. So 15 3/4 years, my amount of money will double. Letter E, how many years would you have to invest $15,000 to have it grow to $1 million if it was compounded continuously at 9.5%? So E, I want to end up with $1 million. I want to start out with $15,000 compounded continuously. So this is e to the, well, I don't know how many years. So that's going to be x times my rate of 0.095%. Okay, so I'm going to get out my calculator again. I'm going to go to y equals. I'm going to plug in my $15,000. But instead of doing an equation, I'm going to go e to the 0.095 because it's 9.5% times x because I don't know how many years. And I want this to be $1 million. Now that's a huge amount of money. So I need my y to be greater than $1 million. So I'm going to do 1,100,000. My x's, I'm going to make 400 because I really don't know. That's probably too much. Let's make it 100 years and see what if we can see it. There's my first graph. There's my second. If I can see it, I can find it. Second trace. To go to the calc menu, number 5 is intersection. Hit enter 3 times. I hit it, of course, 4 times. 44.2. 44.2. So I have to invest it for 44.2 years so that I will get $1 million. $15,000 invested for 44.2 years will be $1 million. Finally, letter F. The number of grams W remaining of a radioactive substance, carbon-11, after m minutes is modeled by W equals 16 times 0.8 to the m power, where 16 is the initial amount. What is the half-life? Remember, half-life means I'm going to end up with half the amount of material. So F, I want to end up with half. So I want to end up with 8. That's equal to 16 times 0.8 to the m power. I need to find m. So I go back to my handy dandy calculator. In y1, I'm going to put 16 times 0.8 to the x power. I want to end up with 8. My numbers right now are way too huge. So I'm going to go from 0 to 10. And here 0 to 10. Now my x's, I might need to go a little larger than 10. Let's go 20. If I can see it, I can find it. Second trace, number 5, 1, 2, 3, 3.1. 3.1. So m is for minutes, so this is 3.1 minutes. That's the end of the review.